how to store and display images in a database. In this video, we will demonstrate how to upload an image into your Blazor app and save the image to a database record. We'll also show how to retrieve the image and update it. We use a .NET 8 Blazor web app with interactive server rendering per page or component. First, we need to create a model to hold the image. Our model will hold data related to a game player with a property to store the player's image. The image is stored in a byte array, but on the SQL Server database, this will be a variable binary field. You can scaffold the CRUD pages for this model by right-clicking on Components and selecting Add New Scaffold Item. From the dialog, select Razor Components using Entity Framework CRUD. In the next dialog, select the model you want the CRUD pages for. Since we don't have a data context yet, click the plus button, and maybe change the name of our data context. We'll be using our local SQL Server database. Click Add to scaffold everything. Once done, our player CRUD pages are in a folder under Pages. We can use the route of the index page and set up a menu link in the nav menu page. Visual Studio also scaffolded a data context class for us. In our example code here, we did some extra setup on model creation because we have a relationship between our player table and player type lookup table. But that's got nothing to do with our image property. A connection string was added to our app settings JSON file to connect to our local database server. Here we just changed the name of the database. Of course, now the database hasn't been created yet. Right-click Connected Services and select Manage Connected Services. From your connected database service, click the ellipses menu and select Add Migration. We'll name our first migration Initial. Once it found the data context class, click Finish to create the migration. Now we can update our database. Go back to Manage Connected Services again and select Update Database from the ellipses menu. Wait for the dialog to find the data context class again, then click Finish to update the database. While you could use your data context directly in your pages, it is more conventional to abstract your repository via a service class. This way you can implement your CRUD methods and their related application or business logic in one place. Rather than repeating this logic in each page, we can simply inject the service into the page. To do this, we added a services folder and created a player service class. Notice it inherits from the player service interface. We'll create that in just a moment. The constructor takes the data context and assigns it to a local variable. Our first method simply returns a list of all the player types from the related player types table. The next method returns all the players from our database, but also includes their player type reference. This method will be used when we build our grid of players. Then there's a getPlayer method to return a single player by ID. An addPlayer method, which will be used when creating a new player. And the update method for editing the player record. Here you can see we copy the new data to the player on the database. Lastly, there's the deletePlayer and playerExists methods used to remove a player from our database. With the player service class done, we added an interface class and named it with a leading uppercase I. We'll be injecting this interface into our pages. The interface simply contains the method signatures of the methods in our service class, without the leading access modifiers. Our final step to finish up our service is to register it in the program CS file. Right, let's look at our players' CRUD pages, starting with the index page, which will display a grid of all our players. The first we did was remove the DB factory and iDispose references and injected our player service. Again, you could have kept the scaffolded DB factory code if you prefer. This won't affect how we deal with the image property. In this example, we removed the image property from the grid. This is more of a details property. The grid uses the queryable players collection we created in the code section. This is filled by our service's getAllPlayers method. On to the Create Player page. This is where we'll start using our image property. Again, at the top, if you've created a service, remove the DB factory and iDispose references and inject the player service. For client-side interactivity, we'll set the render mode to Interactive Server. In the edit form, we add an input file element to allow the user to upload a file. Here we created some custom CSS formatting for the element because we didn't want to display the file name next to the button, and we can set our own text for the button. Of course, you could just use the standard form control class if you like, but if you're interested, here's our CSS. We created a custom .css file in the root folder and added the link to the app.razor file. Back to the input file element, you can set the accept attribute to limit the types of files it can accept. Then the most critical here is the file handling method that fires once the user selected a file. This is where all the magic happens. We create a byte array to hold the bytes from the uploaded image file. If the user did select a file, the event argument's file property will have all the information we need. Here you may want to consider limiting the file size and maybe call some custom method to scale the image. We use a memory stream and copy the bytes from the file to the stream. Then copy the memory stream to the byte array. Now for the browser to display the image, the bytes are converted to a MIME type, which is a string of characters. And before we're done, remember to assign the byte array to our player's image byte array. In the HTML, we simply check if the image string is not null, then display it just like you would any other image. Let's see if this works. When we click the Input File Elements button, it takes us to our local files to choose an image. Once uploaded, the image is displayed. When we add this record, the image bytes will be stored in our database. To see what this looks like in the database, go to View, Server Explorer. Choose your server, and then select the player database. Under Tables, right-click the player table and select Show Data. Here we can see our image bytes being stored in the table. The player edit page is basically the same as the create page, except here we'll need to load the image when the page is initialized. Just like in the create page, we'll replace the DB factory stuff with our player service and set the render mode to Interactive Server. Also, the input file element remains the same with its image file handle method. However, in the onInitialized method where we load the player, we need to set up the image string for the browser to display. Here we convert the image byte array to an image PNG MIME data type. It doesn't matter if the original image file was a PNG or a JPEG file, the browser will display it using the PNG format. There's no change to the image file handler method, and it's still the same as in the create page. Once you've created the image preview string, remember to assign the image bytes to the player's image property. Once there's data in the image preview string, the image is displayed. Let's test this. When we go to edit, the player's image data is converted to the image preview string and rendered. You can also choose a new image for the player and save the update. The player's details page is much simpler. Again, we replace the DB factor stuff with our player service. Here we don't need an input file element anymore since we won't be changing the image, but we still display the player's image when the image preview string is available. In the onInitialized method, we set up the image preview string, just like in the edit page. The delete confirmation page is basically a copy of the player's details page, except it has a delete button and function. Again, we change to our player service and still display the image preview string if available. In the onInitialized method, we set up the image preview string. On a side note, notice we're using the CRUD method in our service to delete the player record. With all that done, we have a full CRUD application for our players with image handling. Thank you for watching our video. For more tutorials on C#, hit subscribe and click the reminder. Give us a like so the video can be visible to more people.